technology to support the warfighter. She earned her Bachelor's of Science in Meteorology from the University of South Alabama in 1996. She earned her Master of Science in Geography at the University of Alabama in 1998, and in her doctorate in climatology from Louisiana State University in 2006. For the last 10 years, she was a physical scientist with the Army Corps of Engineers, assigned to the Engineering and Infrastructure Intelligence Reachback Center, where she was the program manager for the Geospatial Assessment Tool for Engineering Reachback. In 2010, she joined the Civil Information Management Section with the 95th Civil Affairs Brigade of the U.S. Army Special Operations Command as the program manager for the Civil Affairs Operating System. And Lynn, welcome, and welcome to. We're looking forward to hearing from you. And let me pull up your presentation before I start your 8 minutes. All right, there we go.
All right, I may have a southern accent, but lucky for y'all, I talk pretty fast. So, 8 minutes, let's go. So I am Lynn Copeland. I work for the U.S. Army Special Operations Command, and more importantly, the 95th Civil Affairs Brigade, which is a part of USASOC. I am the program manager for the Civil Affairs Operating System, so I have the luxury of standing here telling you that I manage chaos. So we teach chaos, we train it, I manage it. It's awesome. So to really understand what data we have, what data we need, you really need to understand who we are. So real quickly, I work for the brigade. We have these staff sections. SIM, highlighted, Civil Information Management, that's where I'm from. The whole purpose, the main mission of this entire brigade is that we want to eliminate, reduce, and mitigate civil vulnerabilities exploited by our adversaries. So where are these areas of instability and what's causing that instability? At the brigade level, we're looking at this at a global effort. So we're really aligning ourselves to execute the global operations of the Special Operation Forces. Within the brigade, we have battalions. There are 5 battalions, and typically they align themselves with a combatant command. So at the battalion structure, we have the same sections. Below them, there are companies. So whereas the brigade looks at a global mission, the battalion looks at a theater-specific, so our SOUTHCOM, our PACOM, our SITCOM, our AFRICOM, and our EUCOM. Below them, the companies are allowed to look at things more on a regional scale. Now within each company, we have CATs, Civil Affairs Teams. So those are the guys on the ground. This is where our data is coming from. This is who we need to supply data with in order for them to do their job. There are 6 CATs within each company, and they report their data up to a CMOC, a Civil Military Operations Center. That's where our analysis takes place. So they're able to look at the data coming in from the CATs and really step back, or stand back I should say, and say, okay, at a regional level, this is what's going on. The CAT is very important, obviously. These are our guys on the ground. They're our 4-member team. They have their captain, which is their team lead, a sergeant first class, typically running security, a staff sergeant that's a medic. These are Special Forces trained medics. And then they have a sergeant first class that's doing civil affairs. This is the guy that we are after. So in order to go into an area and determine what is wrong, why is this town, this village, why is it unstable, you really need to do your civil reconnaissance. So if you ask the locals, what is your problem, what do you think can be done to help mitigate your situation, and they tell you that we have poor drinking water, then maybe we need to go in and take a look at why. Or if they have cattle that's dying, maybe we need to bring in a vet and figure out what's going on with vaccinations. Whatever it may be, we're having to do a recon of the area. If something's broken, why is it broken? What's its issue? How do we fix it? When we're doing this, yes, we are trying to figure that out, but we are also interviewing the locals. Who's in charge here? Who's making decisions? Who's really influencing this village? So we're gathering information not only about the infrastructure, but we're also gathering information about the people. We do this to determine what needs to be done. How do we mitigate this situation? We may need to instigate a project. We need to build something. Maybe we need to do a medical capability study. So once we decide what we've got to do, then we've got to be able to track that information, because we need to make other folks aware that we're in this area So, civil information management. This is what we're trying to wrap our hands around. You can look at it from a layering perspective. In the very basic layer, we need a base map of the area. This is the majority of why we have such a need on imagery. Where are we and what's going on? And what are the change detection from previous years to even last month? How do we understand the climate? Is this area flooding? What's going on? Are they earthquake prone? Are they hurricane prone? We do that with our base map, our central data layers. We start then looking at threats and what is wrong, what is going on in this area, why are we there? And we start to look at the environment more and who are the violent extremist organizations really operating here behind the scenes. We need to look at that civil terrain. What is that infrastructure? We need to look at what's going on as far as organizations, social groups. We need to look at activities. So who else is coming in this area? Can we partner with any NGOs? What are we doing for the host nation? We've got to have a complete understanding of the area to know what to target. So we have a process, our civil information process. We're collecting data, we're fusing that data together, we're making an analysis, and then we've got to share and disseminate that data to all the players so we can work collectively. That is our business process for CHAOS. The Civil Information Data Processing System is actually our formal name. It is a 3-tier process, if you will. We're collecting data in the field, we're analyzing at our desktop level, and then we're pushing it to a centralized enterprise level geodatabase. We really strive to be device agnostic. We can't keep up with all these smartphones. We have guys in the field that are in their early 20s. You can't make them happy unless you can fit something microscopic in their pocket. So we gave up on trying to say this is our one mobile data collection device. Here is a kit, freaking pick what you want. Get the job done. So you collect your data in the field, you push it to your desktop, you analyze it, make your corrections, run your reports, push it up to our server level so everybody can see it. We have different layers of permissions in our program, so there are people that are tasked with vetting that data, which is very important because once that is triggered in our database, it's migrated to the secret side. So where I said that we're going in and, hey, we're just going to look at your school, I just want to look at your sewer treatment plant, I'm really trying to figure out who's running things here. So we do collect data on people that we need to keep in a secret environment. So our data is migrated from the unclassed side to the secret side, so that additional information can be collected. So this is a process. So all of our data is in the geodatabase. What is so important about this, and literally the reason why the brigade had to step up and say enough is enough, we had teams that were collecting data. The data wasn't structured, it was standardized for them, and it made it really hard to share data when another team was coming in. If you're not familiar with the special ops community, these guys rotate in and out every 6 months. It's fast, fast, fast. And we have to make sure our data is not being stored on an external brick and being stored in a safe somewhere when they come back to the States. So we've got to make sure that all the data is structured. So when I get ready to go to Tajikistan, I can look at my geodatabase and see, what did that team do 6 months prior? Let me bring that data back to my desktop so I'm not duplicating their effort. I have 1 minute? Seriously? That's awesome. Alright, so online chaos is how you look at our data in a tabular form, make your search. We obviously have a Google menu to look through our data. These teams, we are a complete Esri shop. We run ArcGIS Explorer. We have desktop chaos, so we can push data back and forth between our server and our mobile devices. Our mobile devices, we have to be very cautious to yes/no questions, data drop-down menus to make sure our guys are making really quick assessments. So this is my last slide, I promise. I just want to make out a point that I'm very, very, very thankful to the LizardTech guys, and they asked me to do this for them, and I immediately said yes, because Esri dropped the boat when they were working on Art Mobile, and they didn't support compressed imagery, which really hurt us. We had to have our compressed imagery because we're working on such small data files, and we're pushing data back through satellite connections. So LizardTech really stepped up to the plate and helped us work that effort. And now we can use Mr. Sid imagery within Art Mobile now, which is very important for us. So we are currently moving off the ArtPad platform, thank goodness, with the help of LizardTech. So thanks, guys. That's it in an 8-minute nutshell. Great.
you've never done a lightning talk, 8 minutes is really tough. It's really tough. Lynn did a great job, so thank you. And I hope you get a chance to